Greeting Earthlings, welcome back to my channel, the Only Lauren channel. I am Lauren, Only Lauren. Only Lauren does those fancy things she says. Wait, that's not the lyrics. Only Lauren does dun 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 dun. She's so fit, she's so black, just so she'll never die. Only Lauren, it's true. Okay, and so today's lecture we are going to be talking about physics for the little Nikkahz. That's right, y'all, the little Nikkahz. And basically, this is just an introductory physics course. College physics doesn't require any calculus. For people who are just starting out, or if you have children that you possibly want to teach physics, you can show them these series of videos and they will learn it, I think. So just stay tuned, and I'm gonna be teaching you guys off the dome because I feel like maybe that's how I teach the best as far as learning, or as far as learning for myself and then teaching as well. So one of the first things you want to do when you open up the book, this is Technical College Physics, the 3rd edition, and anyone will work, but since this is the book I'll be teaching from, I would like you to go pick this one up too. If there are other later editions, that's fine as well. So one of the first things you're going to want to look at is the these are the metric prefixes. So basically, well, chapter 1 is going to talk about this, but this is the metric system, and this is what we primarily use in the science and physics community as far as measuring length goes. In fact, it's the only one we use. Even though I don't see if you use miles per hour, especially for a kinematics problem, that might be ideal. So, but basically it just goes through each one, but each one means from macros to micros. So if you can sort of, memorize these, you're gonna know them anyway as you start doing more problems, as they talk about them in meters and millimeters, milliliters, etc. And those are just the prefixes. And they're going to, here is also the conversion factors. Just lightly look at those, because I'm not a big conversion person. It either is or it ain't. I'm not going to do that. No, I'm just kidding. No, I'm not kidding at all. If I'm doing one set of, if I'm working with one system, then I'm not going to convert from grams to slugs. I don't even know what a slug is. And they're talking about more conversion factors as it pertains to this dimensions. And time is usually measured in seconds, as when we do physics. They got angles here, 360 degrees, it's 1 radian. I hope you guys can see that. Okay. You probably can't see that. Force. And here they're talking about volume, time, angles, speed, force, pressure, energy, and power. And if you follow this channel, you know that I also do some astrology and of course astronomy. So as far as picking those things up, those types of things are necessary for just that single entity alone. And this is basically all about solving the problems with the prefix is going to be talking about. And as far as our class is concerned, There's going to be a solved example for each problem. You're going to want to get a book that has like that. I love solutions. I can see where I made the mistakes at and redo my work. They have both SI and British system of units, and a summary and definition of each term and important formulas at the end of each chapter. So chapter 1, as we go through this, is going to be measurements and units, and I'm going to cover the whole book because I need something to talk about as far as having content as well. So this has 32 chapters. You can go through, reference this class again in order to learn it. And I don't know if I'll have part 1, part 2 to each chapter as it goes, but I'll try to wrap it up, and I'll just stop when I think it's enough, when I think you're done for, like actual professors do. So in this, what we're talking about in chapter 1 is what we measure. So to sum it up in the most macro and simplest terms, what we measure is length, mass, and time. And everything else is just a derivative of those 3 components. They also threw in volume and capacity. I would actually say capacity before I say volume, because that's the length, but density without the mass would be capacity. So that is another way. We are most often familiar with the equation for volume, just a regular one: length times mass, length times width times height. I'm gonna push you up real quick so you can I'm looking crazy so you can see. So volume, regular volume, is V equals length times width times height. I know you remember that from grade school. Your girl looking. Anyways, so basically length describes an object's size and position in space. Mass talks about the quantity of an object and the amount of matter it attains. And time is kind of characterized as a continuous flow, forward, never backwards, never intersecting. 2 events define an interval of time. And there's also said to be another fundamental property associated with electrical energy called electrical charge, but that's for the more advanced, and those are known as the fundamental properties. So for mass, the most basic of formulas for mass is weight equals mg. That's mass times gravity. Even though weight is not necessarily the same thing as mass as it pertains to gravity, you have to measure it in that circumstance. Oh, that makes sense. So if you've ever seen the amount for gravity, the weight of gravity to Earth is 9.8 meters per second squared. That's the mass. That's mg. So as meters per squared. So whatever weight, no matter what the weight, it's going down at 9.8 meters per second squared. Okay, so the next thing we're going to talk about is density. The most basic form of measuring density is rho equals mv. So equals NV, that's mass over volume. So obviously you have a mass. Can you see that? Okay, yeah, okay. You've got a mass. This is automatically a mass just by it being an object. And the volume, this is the volume, and its force of gravity down with the capacity of the amount of material in the object is density. I hope that makes sense. Anything from here will be a derived quantity. So what is a derived quantity? It's basically what I said earlier. It's a mix and match of all three of the fundamental properties. Basically what the book talks about from the next point is the system of units. When you do a system of units, you're going to want to stick to the same systems of units that you're using for the particular problem. For instance, if you're using meters, you will stay using meters. If you are using grams, you're going to be staying using grams, and so on and so forth. And basically what you want to do when you are understanding your systems of units is understand how many of each length or each mass or how many seconds are going to equal a larger amount of the same kind of quantity. 1,000 meters equals 1 kilometer. Why am I thinking about that? And I think what does it do? We basically, when we're done with those, we condense it down. What is that called? It's when you put the I forgot. And then it basically goes on to tell you how to do a conversion, and I'll do one little conversion for you, and I think we should wrap it up after this. We'll wrap it up after this. This is going to be a simple conversion, just a simple conversion. You have 48 inches, okay? That's the first part. Times 1 foot over 12 inches. Super simple. Super simple. Can you guys see that? All you're gonna do is get rid of the inches, right? Cancel out the inches. So what is 12, or what is 48 divided by 12? That's 4 feet. This is what's going to be left over. Okay? Super simple. Super simple. Well, I'll see you Earthlings in the next video. Like and subscribe and share my video and buy my book Quintessence on Amazon.